Hello and welcome back to PaleoCast. I'm Liz Martin Silverstone.
And I'm Dave Marshall.
And this is episode 140 on Aquatic Spinosaurids with Dr. Matteo Fabbri from the Field Museum in Chicago.
So Liz, it is good to speak to you again. How have you been and where did this interview come from?
Yeah, it's definitely been a while. I've been good, pretty busy because I got a puppy and he now takes pretty much all of my spare time. So I will blame that on not having done any episodes recently. But yeah, other than that, good, just busy with work and things. This episode came from basically just kind of thinking about what would make a good episode. And there's been a pretty recent paper that Matteo and co-authors did looking at the Spinosaurus question and new evidence of whether or not they were aquatic. So I thought, you know what, that actually there's some pretty good science in it. And I think it sounds actually quite interesting.
I can take this intro in one of two ways now. I'm like, do our audience want to hear about aquatic Spinosaurs or do they want to hear about puppies? And I'm not quite sure which way to take it. I think you've referred to your puppy as he. What's his name? You can't not introduce us to him.
So his name is Merlin. He is a corgi. He has tiny little legs. He's very
Is he
cute.
related to the Queen's corgis?
Probably in some very distant way, but not that I'm aware of. But he's a different corgi than most people are used to because he's tricolored. So he's not red and white. He's red, white, and black.
Wow.
Which is different. And he's very cute and barks a lot. And just scratched me as well. So I now have a giant red welt down my leg from where he scratched
Merlin.
me.
Anyway, aquatic Spinosaurs. What made you think that our audience would be interested in those?
I mean, nobody really knows what Spinosaurus is, right? I mean, I don't think anybody's ever heard of Spinosaurus. So I just thought maybe we should introduce our audience to this very unknown dinosaur that nobody has ever heard of.
Was it featured in Prehistoric Planet?
It was not featured in Prehistoric
I've not
Planet.
seen it.
No, it wasn't because Prehistoric Planet is all late Cretaceous and Spinosaurus is early Cretaceous. So it is not in Prehistoric Planet.
How do you know what was in Prehistoric Planet, Liz?
Well, something that was in Prehistoric Planet was me. Kind of. So I was one of the talking head scientific experts in the second episode. So I wasn't actually involved in any of the advising for the show, but I did get to talk about some science and how we know things about pterosaurs, which was pretty cool.
Yeah, that's good. How was the experience?
It was actually really good. It was my first time doing that, like doing a kind of TV thing. And the producer was really patient and helpful and understanding. And yeah, I actually really enjoyed it. It was very strange seeing myself on the TV afterwards. And I'm very thankful that when I went to the premiere, they did not show the scientists on the IMAX because I don't think I want to see my own face on an IMAX.
Yeah, I mean, it's hard enough listening to your own voice back on a podcast, but seeing your own face. I mean,
Yeah.
I am an expert on a documentary, like one for the Smithsonian channel I was talking about, Eurypterids, and I can't watch it back. I just look at myself and I'm like, oh, you didn't iron your shirt, you got a big spot. I am eating chewing gum the whole time and I can see it. And I'm just like, oh, Dave, what have you done?
Yeah, we did about an hour of recording, and in the end, they only did very short snippets with the scientists. So all of them are only about 5 minutes, and I think I'm on screen for something like a minute or 2 minutes, and I'm really glad it's not more than that because watching that 2 minutes of myself was horrible.
So you were there for an hour and then that's cut down into a minute or two.
Yeah, I think that initially it was meant to be longer than that, but in the end they decided to just do quite short bits with scientists, which doesn't bother me particularly.
So were they asking you questions in the same way that we interview people on this podcast?
Yeah, so it was kind of led in a similar way to this, where they had questions, and obviously there was an episode that went along with it. So it was kind of very specific questions and a specific point they wanted you to get to. But it was kind of talking about the science behind a specific clip for me. So it was just one clip with pterosaurs, and it was sort of, how do we know that? What's the scientific evidence behind that? Do modern animals do this? You know, that kind of thing. So it was fun.
This is all freely available on YouTube, isn't it? The clips with the scientists.
Yeah, the clips can be found, so anybody can go find the Prehistoric Planet YouTube page and go listen to me blab about scientific
Or we'll share
selection.
it on our social media. And whilst you're there, audience, you can share our Paleocast episode with your friends.
Could do. That works.
Should do, yeah.
Yeah. What about you, Dave? What have you been up to in the last month?
I have been the one writing documentaries. So, you know, like, you look at the Paleocast crew. Tom is working full-time on a documentary. I'm working full-time on another documentary. You've been contributing to a third documentary. We're all at it.
Yeah, there's so many going on right now, so it's nice that we're all getting involved.
Yeah, but it's pretty intense. Like, coming up with the most engaging things to put on the small screen, or, you know, like a decent sized screen, you know, and coming up with animals or plants that are interesting enough to hold people's attention. It's hard. It's a hard brief, especially in the Paleozoic. I'm just like, well, I've got these amazing brachiopods, and you just look at the faces and it's just like, no, okay, I'll get something else. So
is that...
Yeah, digging around in that, there's so many things that even as someone who is focused on the Paleozoic, that I will just read. I'll just go for a deep dive and find this amazing ecology, just this one fossil or fossil group that gives you a window into a whole ecology or an ecosystem that you just never even thought possible. And it's just like, whoa, no way did I not know about this when we know so much about this one behavior or this one morphology that tells us about a behavior. It's been amazing, the stuff that I've learned.
Is that a full-time gig that you're doing now then?
Yes.
Nice.
Well, it's contract.
Yeah.
But it's full-time contract until the contract is run out.
Sure.
And then I'll be unemployed again. Well, oil stuff.
I was going to say, are you still doing oil stuff?
Yes.
When it exists.
When it exists, I'll do any documentary and oil stuff that you want me to do. Paleontological consultant for hire.
Everybody keep that in mind if you have something coming
or you could just donate on Patreon, and then you could just all collectively hire me and maybe Liz. I'll offer some money around the crew. Yes, but we've not been doing too well with getting episodes out of late, seeing as we're all so ridiculously busy. And so that's why I started this Paleo podcast plug. And today we're going to be hearing from the Paleo Nerds.
Well, hey, I'm David Strassman.
And I'm Ray Troll up in Alaska. Dave, where are you?
I'm in Ojai, California, and we are the co-hosts of the podcast Paleo Nerds.
That's right. I'm an artist, and you are an entertainer.
That's right. But we are both Paleo Nerds, and during the pandemic, we had nothing to do. And so let's do a podcast, which has been very successful, right?
We have over 50 episodes with all kinds of cool people. We have professionals, well-known folks, obscure folks, just random people here and there that just love fossils just like Dave and I, because, you know, I'm as close to being a fossil as one can possibly be.
That's right. We appreciate you, Dave Marshall, for allowing us to plug our podcast, Paleo Nerds, available anywhere you get your podcasts. And of course, we have a website,
paleonerds.com. And hey, Dave, I just want to throw in that when we did the logo, I wanted to do a trilobite so badly. And you said you can't do a trilobite. Why?
Because that is the PaleoCast logo. And I just begged you. I said, no. He was here first. It is my very first paleontological podcast I ever listened to, and I am a fan. So that's why we nixed it on the trilobite, and I'm very glad we did.
We settled for a T-Rex, but I really wanted the trilobite, man. But, T-Rex is all right,
That's right. So anyway, thank you, Dave Marshall, for letting us plug Paleo Nerds on PaleoCast.
So if you've not yet listened to them, make sure you do so and tell them that PaleoCast sent you.
Don't forget to head over to our website and have a look at all the images we have to go along with this episode. And once you've had a listen, head over to social media and let us know what you think. Could Spinosaurus swim or not? And we hope you enjoy this episode. So today I'm speaking with Dr. Matteo Fabbri from the Field Museum in Chicago about his recent and fairly controversial work on Spinosaurs. But before we get going, can you introduce yourself and talk a little bit about how you ended up doing what you're doing now and where you are?
So I am a postdoctoral fellow at the Field Museum of Natural History in Chicago. My postdoc advisor is Jim O'Connor. I did my PhD at Yale, and then I was invited by Jim May to apply for a postdoc at the Field Museum to keep working on the evolution of birds from non-avian dinosaurs using both fossil record and embryological data.
Cool. So most of the stuff you've done, it sounds like, isn't really on Spinosaurus. So how did you end up working on Spinosaurs?
In 2010, I was contacted by the Museum of Milan, who was working with the University of Chicago on the neotype of Spinosaurus aegyptiacus coming from the Kenken beds of Morocco. Mm-hmm. My role in the research was to understand if this specimen was fully grown or not. But when we cut the bones, we noticed that the specimen is indeed osteosclerotic, and that brought the team to think that indeed maybe this dinosaur had very weird anatomical proportions because most probably was adapted to a semi-aquatic lifestyle.
Interesting. So before we get into more on the aquatic side of things, can you talk a little bit about what Spinosaurs are and give a little bit of an introduction into where they've come from, when, and what they are for those who don't know?
So Spinosaurids in general are a group of carnivorous dinosaurs that are from medium to large size. Their phylogenetic placement is still kind of debated. There are some phylogenetic analyses that place this group at the base of Tetanurans, which is this group that includes Allosaurus and T-Rex and all birds. Others see this group as sister to Megalosaurs that are another group of predatory dinosaurs, specifically from Europe and North America. The peculiarity of Spinosaurids is the fact that their face is crocodile mimic, they have conical teeth, and since the beginning of their discovery, it was pretty clear that most probably their diet was including fishes or other little prey in the water. They are globally widespread. Literally the only places where we still didn't find Spinosaurid material are Antarctica and North America. We know around 20 different species that are coming from mainly Gondwana, Asia, Europe, and South America. They live during the early Cretaceous, and their anatomy is very peculiar, and therefore they obviously attracted a lot of attention in terms of research, especially in the last years.
How big were they?
So we have Spinosaurids that are around 5 to 6 meters long, especially from the Iberian Peninsula. The average size among Spinosaurids is around 9 to 10 meters, including example, Baryonyx, Superminus. And then we have estimates for the largest species, such as Oxalaya and Spinosaurus, that are estimated to be around 14 to 15 meters.
So most of them are actually quite a bit smaller than what we think of as sort of Spinosaurus and I guess what most of the public thinks of as a Spinosaur.
Yes, the majority are an Allosaurus kind of size, so they all range around 9 to 10 meters.
You mentioned a couple of them, but how many different species are there?
So in general, we know about at least between 15 and 20 species that are all over the globe, basically. Some of these species are controversial. There are, for example, Irritator and Angasurama. These two different species come from non-overlapping specimens and that are both cranial. And some authors suggested that they were the same species, and some authors say that they are two different ones. Another example comes from Morocco, where there is Sigilmassasaurus and Spinosaurus. And some authors think they are two different species. Some other authors, including myself, think they are the same thing. That being said, there is still controversy regarding some of these taxa, as in any other group of dinosaurs. This is pretty common, especially when material is not abundant, and therefore it's not clear how we can actually test for one hypothesis or the other. But overall, we can count at least 20 species of Spinosaurids, 15 of which are generally accepted.
You mentioned before that there's no sign of them in North America. Do we know why that's the case?
No, we don't know why that's the case. There is only one paper by Allen who proposed that one single ungual has spinosaurid features in it, but it's one single bone, and it comes from the Morrison Formation, if I remember well, that will make this spinosaurid the oldest known. But that being said, it's very difficult to confirm or reject this kind of hypothesis because it's only one bone, and
Sure.
it's neither full of apomorphisms that can literally tell us this is a Spinosaurid or not. Or it's kind of complicated. The fact that Morrison Formation had a large-bodied predatory dinosaurs was proposed in assuming that this could be a reason why Spinosaurids were not around in that ecosystem. But that being said, the same is true for the Kenken beds and for the Baharia Formation, where Spinosaurus was around, but there were several other T-Rex size dinosaurs, and still it's clear that Spinosaurus in particular was around in those ecosystems. So it's kind of very difficult to understand why we didn't find any specimen regarding this group in North America. It could also be that we are probably not digging in the right sediments. Because Spinosaurids were around during the early Cretaceous, and North America doesn't have much of that. We have a lot from the Maastrichtian, we have a lot from the Jurassic, but literally the early Cretaceous is still broadly unexplored. So maybe we will find them one day, but it's still early to say.
That makes sense. What is it that you think it is about Spinosaurus that people are so interested in? Like, why the big fascination in Spinosaurus and Spinosaurs in general?
Well, in part is the historical fact because Spinosaurus was previously described by Stromer, and actually Spinosaurus itself was the first Spinosaurid to ever been found. So it's kind of this enigmatic animal that represents the entire group. And most probably not everyone knows, but the first Spinosaurus, such as the second skeleton of Spinosaurus, were found in the Baharia Formation by Stromer and then described in 1915 and in the following years. But then all the specimens we had regarding this fossil got destroyed during the Second World War. Mm-hmm. And we had to wait more than 80 years before a partial skeleton was actually found again. So it was one of those iconic yet elusive and enigmatic dinosaurs that paleontology was always keen to find and redescribe and rediscover in some ways. The other thing in some ways is the body size of this animal that still is remarkably large. And the other thing is probably its ecology, because all Spinosaurids always received a lot of attention in terms of their anatomy, their ecology. Mm-hmm. And that this new discovery of this new skeleton definitely sparked a lot of debate in terms of its body proportions, its ecology, its weird anatomy. So I think it's a mix of all these three factors in some ways.
So you got involved in this group that had actually found some new material in Morocco, is that right?
Yes.
So how did that work? Did you get to go out and do some digging?
Yes, so I did not take part of the first dig. So this was done around 2008 and I think 2012, if I remember well. But my involvement happened after this material and additional material was collected. So my first involvement was purely for the research that then eventually led to a paper published in Science in 2014. My involvement in the digging happened in 2015, 16, 18, and 2019, where eventually we all came back to the fossil site. And initially, after our first publication, we thought it was exhausted as a quarry. But then we decided to dig a little bit farther within the hill. And that eventually really paid off because there was a disarticulated tail belonging to the same individual that eventually gave us multiple evidence and additional evidence that this animal was truly peculiar in its morphology. And so then eventually this got published in 2020. And we were happy that we didn't give up on the site, obviously, because you can never know what you will find, really. So,
yeah. So you mentioned before that you were kind of brought on to look at the age of the animal initially, and then you noticed that there was something interesting about the bone that you were looking at. So what was it that you found in that first paper that suggested that Spinosaurus might have been swimming or aquatic?
Yeah, so in the first paper, we had basically only the hind limbs and the pelvis that were very well preserved. And then we had some dorsal vertebrae with the elongating neural spines, which is one of the main features that describe the species itself for Spinosaurus. We had one cervical, some skull bones. And so the proportions of the hind limbs were incredibly peculiar because they were shortened in comparison to other predatory dinosaurs. But really, when we were looking at the histology of long bones of the neotype, what we observed is that a medullary cavity was missing. And this was kind of those magic moment in science. It's something that you would never expect, but still it was happening because predatory dinosaurs are famous to have hollow bones. This means that there is a large medullary cavity that is characterizing the inner bone structure in long bones. And this dinosaur didn't have any. So this wasn't present in neurospines. It wasn't present in dorsal ribs, neither in the tibia and or the femur. So in that moment, we understood that something weird was happening. And then it was clear that indeed the bones were pretty dense. And this is a classic characteristic of animals that spend a lot of time in water. So in our first study, we qualitatively described this kind of feature that seemed to be unique to Spinosaurus. But then eventually in a recent paper published this year, we went with more quantitative methods and with a large comparative data set of modern and extinct species. And we figured out that, yes, indeed, the bone density is very high in Spinosaurus, but Spinosaurus is not the only dinosaur to have this kind of feature in their long bones. And another example is the Spinosaurid Baryonyx that shows the same kind of feature.
So you managed to look at a lot of different animals, both living and extinct, for this new data set?
Yes, we had 297 species that were covering the entire amniote tree. We have we use both femora and dorsal ribs. We have around 206 femora and 174 dorsal ribs. And what we did was to quantify bone density across every major clade of amniotes. And we try to include as many different ecologies as possible, including capabilities of flying, capabilities of diving, terrestrial animals, wading animals, and so on and so forth.
So how do you actually quantify the bone density?
So for the bone density, there are several ways you can collect the data. One is synchrotron scanning, the other is CT scan, and eventually bone histology. So for modern animals, we mainly use the CT scan. This is because there is good contrast and it's very easy to differentiate between what is bone and what is medullary cavity. Regarding extinct taxa, what we did was to use predominantly osteohistology and thin sectioning. This is because some fossils do not have a good contrast between the sediment and the bone. Therefore, what we wanted to do was to have the best quality of the data possible, and osteohistology is the perfect method for it because you can study bone tissue and sediment mineralogical composition at the microscopic level. So in this way, we could be sure what was bone, what was sediment, and so on and so forth. So these are the two main ways we collected data for the diaphysis of long bones. And then eventually we imaged these sections and we converted them in images that are in black and white, where black was filming the presence of bone, while white was empty space in the cross-section. That could be vascularization, erosional cavities, or simply the medullary cavity. And then we used the software Bone Profiler, which is freely available, and you can literally use it as you wish. And that allows to quantify the amount of bone versus the amount of empty spaces within a unit of volume. Therefore, this allows you to understand the density of the bone, which is in part the surface determined covered by bone and the surface that is actually empty.
And why does the bone density actually tell you anything about whether something is aquatic or not?
So all animals spend a lot of time in water, usually have a huge problem, which is called the buoyancy control. In other words, if you want to be an active animal in water, what you need to do is to have full control of your body. And because your body density is generally lower than the density of water, if you don't have a high bone density, then you will tend to float in water. Therefore, animals that like to swim and dive usually increase the bone density. There is a phenomenon called osteosclerosis. And in this way, they have more control on their movement within the water column. This does not happen in animals that are just waders or animals that are terrestrial. While on the other hand, on the other extreme, you have animals that fly, and these animals tend to decrease the bone density. This is because they generally want to be lighter in terms of being capable of flight.
How does it work with animals that fly but also dive?
So in that case, you still have an increase in bone density, but it's nothing comparable to animals that only dive.
Okay.
So, for example, animals like aninga or cormorants, these birds have a higher bone density in comparison to other birds that only fly, but at the same time have a lower bone density in comparison to birds that only dive, such as penguins. So in general, they have a higher bone density, but still lower to animals that are specialized to only one ecological behavior.
So where did Spinosaurus end up sitting in the end after you looked at the bone density?
So Spinosaurus has very similar bone density to plesiosaurs, mosasaurs, penguins, whales, early whales, and crocodiles. So it also has way higher bone density than hippos, for example, tapirs, that are animals that are diving underwater, and also to seals and yeah, pretty much these are the ones. So in other words, Spinosaurus and Baryonyx show bone densities that are way higher even for animals we have no doubts are diving underwater. So I think it's a pretty strong evidence that indeed this cannot be by any chance. And what is also supporting this kind of evidence is the fact that large animals such as Tyrannosaurus rex that are comparable in size with Spinosaurus still have bone densities that are lower than hippos. So in this way, it's pretty clear that at least within the theropod realm, Spinosaurus and Baryonyx are really something special in terms of bone density.
So you mentioned Spinosaurus and Baryonyx, but did you look at any other Spinosaurs as well?
Yes, so we looked at Superminus, which is another Spinosaurid from Niger. And this animal seems to have an open medullary cavity. So the bone density of Suchomimus is very similar to other predatory dinosaurs, such as Tyrannosaurus rex or Allosaurus or Masiacasaurus. So this result is not surprising in some ways because Suchomimus was already published as a semi-aquatic animal in 2014. So in the original paper where we first described the nail type, the real surprise of the 2022 study was actually that Baryonyx is semi-aquatic. So in some ways, Suchomimus was already considered a more terrestrial or wading animal rather than an animal that was actually swimming in water.
For all three of these, did you have multiple individuals that you were able to look at, or is it based on one?
Only one. So for the Spinosaurus, we had only the nail type. Regarding Suchomimus, we had an adult individual, and then that was published by Cirino in 1998 already. And regarding Baryonyx, we had the holotype. The reason why we have only one specimen is because material regarding Spinosaurids in general is incredibly rare. So literally, we don't have many Spinosaurus skeleton that we can actually sample. And the same is for Baryonyx. There is only one skeleton that is actually known, and that is the holotype.
That brings me back to a question I was thinking about earlier when we were talking about the first study that you were looking at, the difference in proportion, like the body proportions. And I was wondering if that is based on a single individual or if it's kind of multiple things. Like, how do these sites look? Are they, nice skeletons kind of laid out, or is it just a jumble of bones and you don't really know what you're grabbing?
Yeah, so like the nail type specimen is now complete up to almost 60%.
Okay.
So now we know way more about the specimen. But when we published it in 2014, we didn't have the tail. Therefore, the skeleton or the data available at that time were way lower. So the general reconstruction of the first manuscript was based mainly on also on data that were involved with other Spinosaurid taxa, such as Baryonyx, Suchomimus, and Irritator for the skull. So the kind of skeletal reconstruction that we had in 2014 was basically an average of Spinosaurids, where we just filled in the nail-type skeletal material. That being said, things changed quite a bit in 2020, and so now we can say that indeed this specimen, this nail-type postcranium at least, is pretty much well covered in terms of skeletal portions that are actually preserved. Also, like the brain case of the nail type was found and is still undescribed, but we are working on it. So the back of the skull is now pretty much known. What is basically missing and would be really nice to have, and those are the main empty spaces that we have in the skeletal reconstructions, are cervicals, because we have only one, and the forelimbs. We still don't have much of the forelimbs of that individual. We only have one metacarpal.
So you've mentioned a couple of times the tail and that being quite important. Can you talk a bit about why the discovery of the tail was so important?
Yeah, the discovery of the tail was important because what we were missing in the study of 2014 was a clear explanation of how this dinosaur was actually swimming in water. So what we proposed in 2014 was that this animal was probably foot propelled. But this is kind of weird because animals that actually swim in rivers usually use other propulsive structures. So the discovery of the tail gave a hint on how this animal could move in water. And the reason for that is the tail of Spinosaurus has very long, narrow spines that increase the surface, the lateral surface of this structure. And this is unique among theropods and predatory dinosaurs. And what is even more important in some ways is the fact that zygapophysis, so the articulation between each vertebrae in the caudals, is reduced. And this is very weird because all Tetanuran dinosaurs usually have overlapping articulation of the caudal vertebrae, making the tail kind of stiff. Spinosaurus doesn't, and this means that the lateral movement between the caudals was higher than in other Tetanuran dinosaurs. So
basically, it could swing back and forth more.
Yes, and at least this is what we proposed. And what we did was to contact Stephanie Pierce and George Lauder at Harvard University, who are experts in biomechanics of swimming stuff, including fishes. And what we did was to test what was the functional performance of the Spinosaur tail in comparison to other dinosaurs and other more terrestrial animals. And what came up was that the functional and biomechanical output of the tail is more similar to newts and crocodiles than other terrestrial animals and predatory dinosaurs. So in some ways, the fact that the tail has this weird morphology allowed us to understand that it's functionally advantageous as a propulsive structure. Then was it the only function that the tail had? Probably not, because every single structure in every modern organism has multiple functions at the same time. But it was kind of striking to show that indeed this kind of morphology was advantageous as a propulsive structure.
Was that the first tail that was ever found from Spinosaurus?
Yes, it was the first tail and the one of the most complete ever found for any kind of Spinosaurid. Stromer had a couple of proximal caudals that he found in Spinosaurus B and also, I think, in the holotype, if I remember well. But it was nothing was ever found regarding the most distal portion of the tail. And the comparison between Stromer's monograph on the holotype of Spinosaurus and Spinosaurus B with the comparison of the proximal caudals of the neotype showed that the morphology is basically the same. So this was another confirmation and evidence that indeed the neotype might actually belong to Spinosaurus.
Do you know anything about the soft tissue of the tail, or is this just from what we can see from the bones?
So it's only about what you can see from the bones, and the reconstruction of the soft tissues is based on scars and rough surfaces you can find on bones that are representative for muscle and tendon attachment. And so what we find, especially in the tail and in the dorsal narrow spines, is that the base has a lot of rugosities. That is what you expect regarding muscle attachment. But then the surface, the apical surface of the narrow spines in both caudals and dorsals are generally smooth. So we think this is kind of a suggestion that it was probably skin attaching to the apical portion of the narrow spines rather than tendons and muscles.
And do any other Spinosaurids have tails like this?
Well, we don't know because there is only one recent Spinosaurid that is from UK. It was described in scientific reports and it shows long, narrow spines in the tail. So this could be an evidence that this new taxon is indeed kind of retaining or evolving this kind of structure. That being said, the original paper didn't describe such structure in any functional meaning. Therefore, we don't know if, at the moment at least, if this structure is actually comparable to the one in Spinosaurus or not. We know that Ichthyovenator, which is from Thailand, if I remember correctly, has some kind of narrow spines in the proximal portion of the tail, but the distal portion is not known. And so we are still missing a lot of data regarding the caudal portion of Spinosaurids in general. So we just need to find more specimens to understand the distribution of disease rates among the group.
Does that mean more trips to Morocco?
Yes, but also anywhere else. So that would be nice, but let's see.
So with the evidence that you've talked about so far with the tail and the difference in body proportions and, of course, the bone density, does this mean that Spinosaurus would be diving deep in the water, or would it be more shallow, do you think?
So all the sediments and the formations where we find Spinosaurids are all shallow waters.
Okay.
And they are usually deltaic or riverine. So this means that there is never deep water where Spinosaurids are around. And the fact that they could go underwater doesn't mean that they are adapted for deep water, because crocodiles are diving and hippos are diving as well, but they all hang out in shallow waters.
Mm. So you don't think it was swimming out to sea or doing anything deep?
No, and actually there is no literature suggesting that, to be fair.
Mm. You mentioned the sediments, which is something I was going to ask about, but what other pieces of information are there that we have that supports the idea that Spinosaurs, or at least some of them, were aquatic?
Well, technically, all the evidence suggests that these animals were semi-aquatic.
Yeah, sorry.
Because the one is the sediment, of course, the one is the body proportion and the general anatomy of the animal with crocodile mimic face, and the tail seems to be advantageous as a propulsive structure. The other is obviously bone density, and then we have isotope information that suggests that these animals were spending more time in water, at least with their face below the water surface. So in general, what all this evidence is suggesting, taken all together, is that yes, these animals were probably more adapted to fish in water in one way or the other. And the reason I am suggesting one way or the other is because our last paper suggests that there is kind of an ecological disparity and differentiation among Spinosaurids. So some Spinosaurids might have fed in water such as modern herons wading at the riverbed, while other Spinosaurids might have entered into the water column trying to fish in a more active way. But to be fair, we still don't know much regarding their mode of fishing or hunting. We can now say where was a spot that most probably they were using, but in terms of the actual way they were doing it, it remains still kind of debated. And in my opinion, it's going to be incredibly difficult to demonstrate one behavior versus the other. Because if we look at modern animals, you have both ambush predators hunting in riverine waters, and the other animals that are a little bit more active. But how do you demonstrate this in the fossil record? It's literally basically impossible. What you can say is this animal capable of going underwater, or is this animal not capable of going underwater? But anything else related to its ecology is probably going to be very difficult to prove.
Is there any direct evidence of diet or anything like stomach contents, or is it just based off of like snout and tooth morphology?
No, there are direct evidence. The holotype of Baryonyx shows fish scales in the gut contents, and also some kind of some remains of a juvenile iguanodon, or that are still mixed with the fish contents. Regarding Spinosaurus or any Moroccan Spinosaurid from the Kenken beds, we have evidence of a pterosaur vertebra with a Spinosaurid tooth that is stuck in it.
I forgot about that.
We know that their diet was pretty much spread all over in terms of what they could eat. Further evidence suggests that indeed the Spinosaurids like fish, but obviously reconstructing the exact diet that an animal had 100 million years ago is not as easy, obviously. So.
How does the sail fit into all of this? Is that something that is related to its swimming, or what was the purpose of the sail?
So basically, everyone said anything about the sail. We don't know what it's doing. So there are some researchers that propose that it's advantageous for swimming. Some other researchers said that it has nothing to do with swimming. Some others said it's for thermoregulation. Some others said it's for intra and interspecific social communication. We don't know really. It's a crazy structure because the neural spines can go up to 1.8 meters long. So it's something really extreme. But that being said, there is no agreement on what was the function for the sail. In my opinion, in some ways, we can exclude some of these functions, meaning that the growth rate of Spinosaurus was pretty high, like for any other giant predatory dinosaur. So probably it wasn't used for thermoregulation. But that being said, it's very hard to demonstrate anything really. So,
is it only found in Spinosaurus?
So there are other sails around. We have ornithischians such as Oranosaurus that have large sails in the back. There are other dinosaurs such as Concavenator that have kind of dorsal structures similar to a sail. We have obviously Ichthyovenator that shows some kind of sail in the back. But that being said, it's very difficult to infer anything about their function anywhere. So we don't know what the sail was doing in other dinosaurs. We don't know what it was doing in Spinosaurus. And so it still remains kind of a mystery, really.
Now I have to ask, because since asking you to come on the show and writing up questions for you, there was a recent paper or a preprint that came out contradicting what you had found about the aquatic side. So I just wonder if you have any comments about that. I think it's mainly based on the air sacs and saying that Spinosaurus would have been too buoyant, basically, to swim. What are your thoughts?
Yeah. So I wrote a preprint counteracting that preprint. So I can tell you that both responses were submitted to Nature and they were rejected within an afternoon because it was kind of embarrassing. But my point for that preprint is the fact that there are a lot of misleading statements. For example, the fact that in the preprint are confusing density with mass, that's problematic for me. The fact that they suggest air sacs in the caudals and dorsal vertebrae when there is no pneumatization in the dorsal and caudal vertebrae, that's another problem for me. The fact that they suggest high bone density is only present in the hind limbs when in our recent paper we clearly showed that it's all widespread, including in the metacarpal, neural spines, dorsal ribs, and tibia, and so on. That's also kind of problematic for me because if we are just ignoring evidence just to make a point that we prefer, I don't call that science, I call that opinion. And so anyway, we will see what will happen. I do not expect that debate about ecological adaptations about Spinosaurids is gonna be resolved anytime soon. At the same time, I believe that the only way to go to better understand these animals is to listen to evidence. And ignoring evidence only because you don't like that hypothesis, that shouldn't be neither part of a scientific debate.
Fair enough. Now, are you still working on Spinosaurids at all right now?
Yes, I'm still working on Spinosaurids, and I am currently working with other groups on different species. And on the other hand, with the Can team, let's call it like this, we are still working obviously on the nail type. So we have a bunch of papers that we are planning to do. Including some further description of the nail type, obviously, that is in preparation as a monograph. We have additional papers discussing the function of the hind limbs, in some ways, description of the brain caves, of course. And we are trying to do some other work on the feeding ecology of the animal. So I believe that Spinosaurus, yes, sparked a heated debate, but at the same time, it's just the beginning for this kind of new understanding of ecological diversity of dinosaurs. Because I think that in the last 10 years, we started from a complete polarization of the field where there were researchers suggesting, yes, it might be that there are semi-aquatic dinosaurs, and other researchers completely rejecting the hypothesis. And although we are still debating on how exactly this animal was hunting in water, even recent toxic preprints are still putting this dinosaur into water. So I think the kind of idea of our understanding of ecological diversity among dinosaurs is dramatically changing. And we are starting to realize that maybe we underestimated the ecological diversity of non-avian dinosaurs for centuries. So I think that although the Spinosaur debate is becoming more and more intense, is definitely leading to a more open-minded vision of the lifestyle of these animals.
So lots of things still for us to learn from Spinosaurus and other Spinosaurs.
Yeah, for sure.
And I mean, your postdoc now in Chicago is on birds, right? So are you able to involve any of this work on Spinosaurs with what you're doing in Chicago?
Yes, we are currently trying to understand how the evolution of birds relates to their ecology. So the work that we have currently going on in Jean May O'Connor's lab is the fact that we want to try to infer what's the ecology of stem birds and how this is different from the early radiation of crown birds after the mass extinction. So we are still trying to understand how the disparity, ecological disparity of several taxa and groups is indeed kind of comparing to the proper radiation of crown birds. So we will see what will happen. But yeah, it's still in a preliminary phase, and we are still trying to collect more and more data to further understand how we can infer ecological diversity in the fossil record.
Sounds very cool. Now, I just have one final very difficult question for you, which is Spinosaurus your favorite dinosaur?
It's not. My favorite dinosaurs are actually Baryonyx. This is because it was one of the first dinosaur skeletons that I have ever seen in my life. And this happened I don't remember exactly the year. It should have been around 2011 or 12 when I went to visit the Natural History Museum in London. And I remember Paul Barrett and Sandra Chapman bringing me into the collections. And Baryonyx was one of the first dinosaurs that I have ever seen, and I fell in love with it. And the other dinosaur that I really love is Allosaurus. And the reason for that is because I believe that Allosaurus is the perfect example of what a predatory dinosaur is, because it has all the traits that make a predatory dinosaur as such. And it's just beautiful, in my opinion. So.
Well, that's great. I think it's really great that you get to work on something that was, your first dinosaur that you got to see. I think that that's fun. So very cool.
For sure.
Well, thank you very much, Matteo. I certainly learned a lot about Spinosaurus and Spinosaurs in general. So thank you for joining me today.
Thank you for inviting me.
PaleoCast was brought to you by Dave Marshall and Liz Martin Silverstone, with contributions from Tom Fletcher, Vish Venkat, and Elsa Pancharoli. Music was composed by Patrick Kendall Smith. PaleoCast was made possible by funding from the Paleontological Society and the Paleontological Association, but the show now relies on funding from you, the listeners. So, if you've liked this episode, please consider donating, and thanks to everyone that's helped out so far. Please visit paleocast.com for the supplementary material to this episode and for our archive of past programs, and follow us across social media platforms to get all the latest news. Finally, if you enjoy our podcast, then please explore all of our video content on YouTube and follow our other projects, the Virtual Natural History Museum and the PaleoCast Gaming Network.